Well, the stuff that we've covered so far is going to be part of your daily life at the command line, but we haven't even really got into anything to do with system administration, managing users, software, that kind of thing. So let's talk about managing the system and all the stuff that goes into managing the system. Now remember, ideally, you're learning this in kind of an agnostic way, meaning that you remember that GNOME is just the window dressing, it's just the thing that runs on top of Linux proper. And you may not necessarily be using GNOME, like an OpenSUSE. We did our OpenSUSE installation, and there's KDE on our OpenSUSE installation, so things are not exactly the same. Let's take a look at users and user management and password management and learn a little bit of the vocabulary, a little bit of the stuff that sort of goes with with the terminology, if you will, in this part of the system. So I'm just going to go to the actions thing, and I'm going to type passwords. And we can see that two things have come up. I've got users, so I can add or remove users and change your password. And then this sort of passwords application thing. I'm going to cover this passwords and keys thing because this is a GNOME thing. And yes, you can install GNOME applications on KDE. On OpenSUSE, you can use the package manager to install this. And you can still use, you can use GNOME and KDE at the same time. There's no problem with that. This is a GNOME application for managing passwords and keys. Now, if you're not familiar with it, public key encryption, I can have a little segue here real quick and talk about public key encryption and certificates and things like that. So when you remote into a system or when you log into a system, you put in a password. A password is really not good in terms of security. It's too easy to brute force passwords. People too often use the same password. It's just not great in terms of security. A much better setup with system security is something that involves maybe a password to unlock a key and then a cryptography key that actually lets you into the system to actually do stuff. With public key encryption, it basically involves two really large prime numbers. It's like, quickly, factorize 101 or, quickly factorize, some arbitrary random number. And if I give you a number who's a very large number, and there are only two factors of that number are two other very large prime numbers, it's going to be really hard to figure out what the factor of that number is, assuming that that number only has two very large prime number factors. And that's basically how encryption works in a super oversimplified nutshell. So with encryption, I pick two very large prime numbers, and one of those I arbitrarily say that that's my public key, that's a key that I can share, and the other one is my private key. I never share it, I never do anything with it. And a lot of things work on that principle. Pretty much all modern encryption sort of works on that principle, involving very large prime numbers. And you may have heard of PGP, Pretty Good Privacy. The GNU implementation of that is GNU Privacy Guard, GPG. Yeah, the whole less is more thing again. Yeah, it's the whole less is more thing again. And so passwords and keys, it's like we see passwords and we see login, and we see that that's unlocked, and I can say I can add a new key or item to this, and then we see certificates. And so sometimes you see the whole public-private key thing written as a certificate, because with a certificate there's maybe a chain of encryption keys that are involved. So maybe if I'm in a business, my my LDAP server or my boss has a certificate, and he signs my key and says this key is legit, and so that would produce a certificate chain all the way back to whatever. That's kind of how SSL works. If you sign up for an SSL certificate, like for a website or for signing software or something like that, you're in a situation where somebody is saying, yeah, that person is good. So when you sign up with VeriSign or Let's Encrypt, you generate a public key and a private key. You give your public key to them, and they say, okay, we will create a certificate that signs your public key and says this guy's public key is legit. This is who they say they are, or whatever. That's kind of how it works on the SSL website. So when you get the little the little lock or the little check mark or whatever on the website that says this is a legit SSL, it is because the public key that you have given the certificate authority has been sort of countersigned by their setup. They use their private key to generate this thing, and then this thing is basically them saying you're okay or you're legit, and that's literally all it is. It's just a chain of trust, because theoretically, they wouldn't have used their private key to sign that your public key is valid, and that's kind of how PGP works. Pretty good privacy. It's like there's a directory of mapping of email addresses to public keys, or at least a fingerprint of a public key at least. And so that's how you verify someone's identity, because the only person that could, decrypt that is somebody that has their private key, or the only person that can verify the signature is somebody that has a private key that corresponds to the the public key, the thing that you've done there with public key encryption. So this is for managing that, and that's what this is on the system, without getting too far in the weeds here. And so your computer might trust things, your user account might trust things. You may have multiple pairs, you might have multiple key pairs, public and private keys on your system for doing different things. OpenSSH, this is a remote access thing that we're going to talk about in a little bit. And so when you SSH into another system, the system has its own sort of fingerprint. You could upload your public key to a remote system, and then the remote system, when you try to remote in, if you have a private key that corresponds to the public key that you have provided, then you would be able to connect to the machine and log in, because the interface would be decryptable at that point. The remote system would know that it's using its private key and your public key to do its thing, and so you can decrypt it and you can have a conversation. And so it is assured that your identity is who you say it is, and it's secured by that private key as opposed to a password, which is a zillion times more secure. And so OpenSSH, this is a really, really sort of secure way of doing this. And incidentally, if you're like on a Windows system or even on a Mac system, the same technology underpins pretty much everything that's there as well. So you talk about, like the certificate snap-in on a Windows management system, or like on a Windows system. It is just managing all those chains of trust. You might have seen the news, big news stories about, Lenovo and some other companies installing their own certificate on a server saying this is a trusted source. Well, then they can, create their own SSL certificates. And theoretically, they could create an SSL certificate for Google or anything. And then your computer that was trusting the Lenovo certificate would trust anything that derived from the Lenovo certificate. So it's you got to be careful what things your system trusts. And so this is an application for sort of keeping an eye on that. You can hit the little plus here and add something. It's like, oh, I want to add something to the password. I want it to save my password. It'll use it'll use some cryptography to deal with that. It's like, oh, I'm gonna use to request a certificate. I'm gonna make a secure shell key, safely store a password or secret, used to store application password. So this is a GUI, but this is something that's provided with GNOME. And if we check, we're on Red Hat right now. If we go back and we look at our Debian system, we can see that it's a lot of the same thing. But the question then becomes, is like, where is this stored in the system? Is this stored in the CLI? And the answer is yes. You can get to all of this through the CLI. This is just sort of a convenient GUI. Then you may say, well, what about OpenSUSE? Well, OpenSUSE has something similar, but it's not exactly the same. See where we're managing like GNU Privacy Guard, GPG, things like that. We've got the KGPG interface. We also have Wallet, KDE Wallet, which is not exactly precisely the same thing. It doesn't exactly work the same way. They're not meant to solve exactly the same problem between the password and keys application and KDE Wallet. There's some overlap there in functionality, but it's not exactly precisely the same. This is why I think that a lot of people struggle with Linux and understanding, is because if you just dive right into the GUI is not really a perfect 100% one-to-one representation of everything that you can do with the underlying system. A lot of the time, the GUI utilities are really just built to make life easy in one aspect or another, but it doesn't really give you the whole universe of everything that you can do, with a key or with SSH keys or things like that. Like, for example, you can restrict what command, like if somebody is going to SSH into your system, you can restrict what command they're able to run when you add their public key to your system, maybe to their user account or whatever. And very often it's not the case that you can do those kind of things with these keys. Like, for example, we just created a test secure shell key, and I'm going to check the owner of this key is authorized to connect to this computer. Well, there's a lot more I could do there other than, like, if they can connect to the computer, there's a lot of stuff that they can do. And so that's not actually like the best thing in the world that this is the situation with this, because I could do some stuff here that, you know, is more complicated. It's possible to do things that are more complicated from the command line than the GUI really gives you options for, like restricting the application that you can run with a particular key. Now, they might add the feature, or there may be other features that are buried here, but a lot of people in the Linux community, a lot of the programmers that work on this kind of thing, know this, and so it's sort of a chicken and egg problem. No one wants to write a really complete GUI to do stuff, and the people that would write a really complete GUI to do stuff probably know how to do it from the command line. And so they'll just say, well, the command line is good enough, because you're really seasoned, you know, the extra salty system administrators, they're going to read the textual configuration file to manage this and be able to do that. And the real thing that I want to discuss here is really just user management. A lot of these concepts are more advanced concepts, but something that you should be aware of. And I really just want to talk about this in the context of user management. This passwords and keys thing is really just for an individual user to manage their own passwords and keys and certificates and things like that that have been loaded by the system, or that have been loaded onto the system. So to really get into user management, we'll open the user management GUI. And again, keep in mind that, you know, this GUI is not complete, but there you go. Now, one thing that you get in the GUI that is very difficult to set up on the command line is we have to unlock it, because, you know, it's locked. We have to put in the password. So now we can add a user. We also have automatic login. So, you know, if this is a workstation and somebody doesn't want to put in their password to log in, you can turn that on. That is a little tricky to do from the command line, depending on the system. But this, again, is something that GNOME provides. It's pretty much the same experience on the Debian side of things, because, you know, it uses GNOME, and GNOME provides a lot of this, you know, functionality as like a core feature of how they operate. If we switch gears for a second and talk about OpenSUSE, and we go into User Manager, we can see it looks kind of similar, and we can add a new user, but the interface is a little different, and this is because this is using KDE instead of GNOME. With the User Manager unlocked, let's add a user and see what options it gives us. Okay, so account type, standard or administrator, full name, username. I can pick something on the system. Allow the user to set a password on the next login, or set a password now. Enterprise login. What is enterprise login? Oh, it's a domain username and password. So this is like LDAP integration, or you know, Active Directory integration, or something like that. So we're not interested in that right now. And these are really the only options that you get in the GUI, and so you can add a user that way, and that works completely fine. But if we drop to a terminal, I want to show you something. I want to show you the etc. folder. So etc., you know, we talked a little bit about all the files that are in slash. And so if we look at slash, we've got, you know, bin, boot, dev, etc., home, media, mount, opt, proc, root, run, srv, sys, temp, user, var. And these are all directories, especially if you're going to go for your certification. You need to be familiar with these. When I ask you off the top of your head, you know, what does proc do? You know, what's root? What's the run folder on Red Hat? You should just immediately be able to come up with answers to those questions. And a lot of that you can get just by reading the man pages. A lot of that we're going to go through, if not in this course, in the more advanced course. But etc. is one of the most important systems, one of the most important folders on your system for two reasons. One, it has a lot of the system configuration in it, and on a particular system, the etc. folder is likely to be the most different. If you accidentally do something really bad to the bin folder, or you accidentally, you know, do something really bad to one of the other folders, with the exception of var, because var has a lot of system variable information in it as well. Just remember var is variable. So like var log, the system logs, things like that. Etc. is configuration, and like /var/mysql maybe would be like your MySQL databases. So these are important directories on the system because they're not going to be the same from system to system. I mean, really none of the other folders are going to be identical either. but it's not the end of the world if you accidentally, wipe out libc, your system libraries folder, or stuff under bin. That is kind of a recoverable situation, especially if you have other identical systems. You could pull binaries. There are ways to run the package manager on these systems and have it reinstall. But if you wipe out etc., or you wipe out stuff under var, that is likely to be an unrecoverable oh crap, let's go to the backups type situation, because those are going to be different on every different system. And etc., the very first things that are in etc. are password and shadow. So we can see the permissions are already looking pretty funny. The password file doesn't actually contain passwords, just contains users. We'll look at it. We'll use cat to look at it in a minute. You're probably already ahead of me. And shadow is where the passwords actually are. And as you can see, there's no permissions on shadow at all. This is done to make it harder for people to try to brute force your password. Even though your password is hashed, meaning that it's very, like, your password is scrambled in such a way with an algorithm that is not reversible. Like, you can't take a random string of your password, like the hashed password, and then go back to a plain text password easily. You just have to compute all possible passwords and then save a database of all the hashes and do that, which is something that people have done. So then you have something called salted hashes, where you add something that's system specific to everybody's password, like adding a couple letters to the end of it or whatever. That would be a very basic hash. That's not actually what's happening. And because every different system computes the hash a different way for a given fixed password, it will defeat the whole, like, look up the password kind of thing. It's not really a big deal. It doesn't really exactly work that way. But if we less passwd, we can see that we've got, these are all the accounts on the system. And when we were looking at the GUI, it was like, well, only Wendell is on the system, and we see that Wendell's user ID is 1,000 and the group ID is 1,000, and then we can see some other information here. This is like the plain text version of this, and then we see that my home directory is home Wendell, and then we see bin bash, which we can guess is the command interpreter that we already talked about. The born again shell. We already covered that. Remember that? That was forever ago. I can't be expected to remember that. So it's like TSS, account used by the Trousers package to sandbox the TCSD daemon, dev null, and /sbin/no login. It's like, okay, user for geoclue /sbin/no login, real-time kit, pulse audio, this kind of thing. Now, the /sbin/no login as a shell on Red Hat, it's different on different distributions. It means that these accounts are not permitted to log in interactively. So these are things that if we do a ps aux less, which is the command that lists running processes on a system, we can see that user, a lot of processes belong to root, the highest level admin user. But we can see it's like, oh, paulkitd, rtkit, ahvi. And so this is a separation of privileges. If something goes wrong inside this process, it's not going to be able to, interfere with another process that's running as root, which is a really, really good thing. We can see that, we've got postfix running here, which is our internal system messaging program. It's actually an email daemon, but a lot of the time Linux uses some type of internal email system for messaging and notices and stuff like that. And so on Red Hat, postfix is installed by default. But strictly speaking, that is an internet mail thing. And so we can see that, there's a lot of stuff running as the Wendell user, as one would expect, because I'm logged in interactively. I'm logged in my graphical shell here. But if we list password, this is, really what PS gives you is just a number for the user. And then PS is smart enough to convert the number back into a user. So when you do ps aux, it's really just saying, it's like, oh, your login manager is running as user ID 42, and it'll just go ahead and expand 42 into being GDM. This is also something, it's a little bit amateur hour, but if you have somebody that's doing something bad with your system, they might log onto your system as QEMU or SASL auth or RPC or whatever, because they would just change the password for that account, and they would change it to where that account is not necessarily using /sbin/no login anymore. Maybe it would be using /bin/bash or something like that. It's not really something that you can, that alone, there's so many other vectors for doing that kind of stuff, and that's so easily detectable that sophisticated people will not even bother with that. But something to keep in mind.